Hello everyone, welcome. I hope you all are doing good. My name is Sambhav. I will be your senior math instructor for this session, and the chapter that we are going to cover today is areas related to circles. Now, one thing, do we know about circles? Yes, we are aware of this shape, this very basic 2D shape. But what is areas related to circle? Okay, don't worry, I'm gonna tell you everything. So, as I'm telling you, that this chapter is about areas related to circles, not the area of exact circle only. So, are there things that are related to circles? Yes, we have been seeing different terms, no? From a very long time. If we talk about circle, we are having different things, the area, the circumference, and everything, correct? Then we saw chord, the arc, and everything, correct? Now, using the combination of these different things, we are gonna have different type of areas. I'm sure you love to eat pizza, no? Then you are doing what? Whenever you are having any pizza, you are taking a slice out of it, no? So, are you eating the full circle or a portion of that circle? Slice only, no? So, now you don't know how to find the area of that slice, correct? How much circle you are eating out of the whole. So, how to find this? We are going to talk about this today. So, as we know that the name of the chapter is areas related to circle. So, somehow we are gonna keep circle in our picture, but not the exact circle. Sometimes we may not be seeing the full circle also. So, what are different things related to this? But before that, let's talk about what are we gonna talk about today in this session. Of course, the introduction part would be there. Then we are going to talk about area of a sector. What is a sector? Then area of a segment. So these are two different things that we are going to cover today. So these are the areas that are related to circle. These are portion of circle only, but how to tell that this is a sector, this is a segment, that also we are going to cover, and how to find the respective areas also we are going to cover in this session. Now, in earlier classes, we have been talking about circles from a very long time, no? So, in your earlier classes, you understood the basic geometric shape, 2D shape, that is circle. Then you understood different things about circles, such as the circumference of a circle or perimeter of a circle. Then area of a circle, you know how to find. The formulas are 2 pi r for circumference, pi r square for area, correct? Now, then we saw different things related to circle. Let me use the pen. Okay. Now, suppose if I'm having a circle like this, then area of this circle I can find using pi r square. R is the radius, correct? Pi is a very constant value, so 22 by 7 or 3.14. Then circumference is nothing but the boundary of this circle, the length of the boundary, that is what? 2 pi r. Also using radius and pi, I can find the value. Now suppose if I am having 2 points on this circle, A and B. So this length or this portion of the circumference is known as what? The arc of the circle, correct? Correct? This is known as the arc. Then if I am drawing a line segment randomly which are joining any 2 points on the circle, then this line segment will be known as chord, correct? Now as you can see that this line segment is dividing this circle in 2 parts, not exactly equal but in 2 parts. Then suppose if we are talking about the longest chord which is passing from the center, that is known as the diameter of the circle, which is having length exactly equals to twice of radius, correct? So diameter is the longest chord. Now this diameter is dividing this circle in exactly 2 parts. One more thing. Suppose if I join two line segment with center and any point on the circle, then this is a radius, this is also radius, no? Radii of the same circle are equal. Now these two radius are dividing this circle also in 2 parts, correct? This bigger portion and this smaller portion. So this is what? What is this thing? Also, when we are looking at this portion, what is this portion? What should we call this? So these are basically the sector and segment of a circle, So we are going to talk about them today, how to find the area and everything. Even in one of the problem, I will be telling you how to find the length of an arc. They are very much related only. You just need to understand the logic, what is happening, then you will be solving problems automatically. Okay, now perimeter. Of course, we are going to use perimeter in this chapter. We are going to talk about perimeter. Perimeter is nothing but the length of the boundary of any 2D shape. Usually we call it perimeter for all the major shapes, be it rectangle, square, triangle, anything, we call it perimeter. But in case of circle, we are having a different name. You can call it perimeter, but you can call it circumference also. So in case of circles, we are having a very unique name known as circumference. So they are same thing. So what is circumference of a circle then? The length of the boundary of the circle. Okay, now circumference is the distance covered when you travel once completely around a circle. So this is same thing. This is same thing. Suppose if I am having a circle, this one, if I am starting from this point and if I am covering the whole distance and will reach the point again, the same starting point, then I am covering a full circle, correct? So this is known as the circumference of this circle. Whenever we are taking a round once, a complete round of the circle. Now, understood the main part? So, an arc is nothing but the portion of a circumference, correct? Now, from earlier classes, it is known that the circumference of a circle always has a fixed ratio, of course. Circumference of a circle will always be having a fixed ratio. Fixed ratio with what? To the diameter. So circumference and the diameter of a circle will always be having a fixed ratio. You can increase the size of the circle, you can decrease the size of the circle, but this ratio will always remain the same. Now, this fixed ratio is known as pi. Remember pi? The value is 22/7 constant or 3.14. Just to ease our calculation, we are using 22/7, but the exact value of pi is not known because there are too many values after decimals, correct? Now, and is represented by the Greek letter this pi. So this is pi, correct? Now, in other words, the circumference of a circle always pi times its diameter. So this is the basic relationship. Whenever we are dividing the value of circumference of a specific circle by its diameter, then we are going to get pi. Now, we can transpose this diameter to right hand side, so the circumference value will become pi into diameter. Diameter is what? Diameter is twice of the radius. So it means 2r. If radius is r, then diameter is 2r. So change it to 2r. So it will become pi into 2r. Finally, we are going to get 2 pi r. And we know this is the formula to find the circumference of a circle, correct? That is 2 pi r. So this is how it is we can derive this, correct? Now we know the relationship between the perimeter, circumference and the diameter, that is known as pi. We are going to use this pi in other places also. Like in case we need to find the area of a circle. What is area of a circle? Pi r square. Pi value is constant, 22/7 or 3.14, and if you know the value of r, you can easily find the area of circle, correct? Now, but we are majorly interested in sector and segment in this chapter. Let me ask you one thing. Why are we calling it a sector? What is sector? I will explain this thing, but I'm just asking you about the why the name sector. Sector is a Latin word. Sector actually means slice of something, correct? So now basically, whenever we are having any pizza, so suppose this is a pizza, so we are having different slices, correct? Then we are taking one slice out of the pizza. So basically we are taking a sector. If you look at these slices very carefully, they are being cut in such a way, the points, the pointed ends are meeting at the center of the circle, correct? Suppose this is the center of the circle. So pi will look something like this, or slice will look something like this. Now, looking at this slice, so what can I see here? One thing, this is center. Suppose this is O, this point is A, this point is B. The line segment joining the center and any point on the boundary of the circle is known as radius. So OA is what? Radius. Same we can say for OB. OB is also radius. So it means this sector is nothing but the area enclosed between two radius, and this is what? Arc. Same is written here. A sector is the region enclosed by what? Two radii and the arc between them. Let me use better image. Now, as you can see here, this is the whole circle, but the faded part is showing you the sector of this circle. How can I call this a sector? So this is the center. Suppose O. This is point A, this is point B. OA is the line segment joining the center with any point on this circle A, correct? So OA is what? Radius. Suppose the value is R. Same goes for OB. OB is also the radius, R again. Also, this faded region is enclosed by two things, two radii and the arc. AB is the arc, correct? Now, this is my sector. The faded region is my sector now. So, what is the definition? A sector is the region enclosed by two radii and the arc between them. That is sector. As I told you, sector is a Latin word which roughly translates to pi or a portion of something, correct? Slice of something. So this is looking like a slice, no, of this circle. So that's why it's a sector. Now, types of sector. As you can see, as you can observe here, look at the faded part. This faded part is the area or the region enclosed in between two radii and arc, correct? But look at the other part, which is solid orange in color. This portion is also in between two radii. One second. Yeah, this region is also in between two radii and this arc. So can we call this a sector also? Yes, this is a sector also. So how to differentiate between these two? As we can see, this is very small area, this is very big area. So depending on that, we can call them minor sector and major sector. Now, minor sector means smaller in area, is always having angle lesser than 180 degree. Now, how come angle coming into the picture now? Now, look at these two radii. They are in such a way that they are looking like arms of arms of one angle. No. Now, in between them, there must be some angle, correct? So if this angle is having value lesser than 180 degrees, then this portion is minor sector. Minor sector. If value of this angle is greater than 180 degrees, then this is making major sector. So if you are looking at this angle is having value greater than 180 degrees. So that's why this is major sector. Major sector. Understood? The difference is the area, of course. This is smaller than this one, no? So that's why. Now, if somewhere is written that sector only, if in the problem it is not given that they are talking about major sector or minor sector, simply written sector, then you will always consider it to be the minor sector. Okay, if not specified and it is written sector only, then you will talk about minor sector only or the smaller portion always. Now one thing, we understood what is sector, but then how to find the area of sector? How to find the area of this portion only? Is there any way? For complete circle, I know the formula pi r square. How to find the area of this portion? Remember unitary method? If you know the value of something, you can first convert it to be the value of 1. Then you can easily find the value of how many you want. Correct? Unitary method, very basic method. Maybe in 6th or 7th class you understood that method. So we are going to use this method now here. Do we know the value of angle for a circle, the complete angle? Always fixed value we are having, 360 degrees, correct? Here these two radii are making some angle in between them, correct? If somehow I can find the value of area of this circle when angle is 1 degree, then for whatever value I am multiplying this, I am having in between them, if I multiply that unitary value with the angle, this is gonna give me the area of this portion, correct? So this is what we are going to do. We are going to use unitary method here. Angle of sector. First, of course, we need to realize what is this angle now. Now, angle made at the center by two radii, of course. In between, there are two radii, because sector is the area enclosed between two radii and arc. So these two radii are making some kind of angle. It can be any value. Measured in degrees, and usually we call it theta. Another Greek letter, theta. So this angle theta value, if it is given, then we can easily find the area of sector. How? I will explain, but understand this. If the value of theta and radius is given, easily you can find the area of sector. Total angle of a full circle. In a circle, the full value is 360 degrees. So theta is a portion of this 360 only. Correct? Now, area of sector, area of full circle is pi r square. That is known. Understood? Full circle corresponds to 360 degree. It means when angle is 360 degree, area is pi r square. Now let me ask you, if angle is 1 degree, then what is the area of circle? 360 divided by, pi r square divided by 360, unitary method. So this is what we are doing. Area for 1 degree, when angle is 1 degree, pi r square by 360 degree, correct? Now area for theta degrees, when angle is theta degrees, then what is the area of the circle? That would be theta by 360 into pi r square. You can even multiply theta here also, or you can write the formula like this also, pi r square by 360 into theta. That is also fine, because we can change the position if numbers are in multiplication, doesn't matter. But why are we keeping it like this? Because both are values of angle only. So you can easily eliminate the common factors. That is giving you some kind of fraction. No? So if there are common factors, you can easily eliminate the values. Now understood? Let me explain this again. Whole circle is having area pi r square. Whole circle corresponds to 360 degree because the complete angle is 360 degree. Now using unitary method, if area of circle when angle is 360 degree is pi r square, then area of circle when angle is 1 degree would be pi r square by 360. Then area of circle when angle is theta degrees will become theta by 360 into pi r square. So you are not doing anything, you are just multiplying the area of circle with theta by 360. If you know the value of theta, if you know the value of r, you can easily find the value of area of sector. Correct? Now let's try this knowledge using one example. So area of sector, again the same formula we are going to apply. This one, r is the radius and theta is the angle in degrees. Now here in this problem, we need to find the area of sector of radius 4 centimeter. So what is given? Radius value is given to us 4 centimeter and angle 30 degrees. What is this 30 degrees actually? Theta. Theta value. We need to use the value of pi as 3.14. So that is given to us. So we are going with that only, 3.14. First thing, we are going to write what is given to us. Now, radius value 4 centimeter, theta value 30 degrees, and pi we are going to use as 3.14. No need to mention, but if you are doing, no problem. Again, remember the formula of area of sector. What is the formula? First, area of sector is equals to theta by 360 into pi r square. Right? Now, theta value is given, r value is given. So it will become theta 30 by 360 into pi is 3.14 into r square means 4 square. 0 and 0, 3 to 36 by 12. So 4 square is actually 4 into 4, correct? So with this 4, I can divide this 12 by 3. Now the equation will become 3.14 into 4 divided by 3. So the final value after calculation will come out 4.18. I already did the calculation. So if you calculate this, you will find that the final answer is 4.18 and unit would be centimeter square, because area will always be a squared unit. So 4.18 centimeter square is the final answer. If you are getting anywhere in between 4.16 to 4.20, fine. Now this is my final answer. See how easy it is to find the area of sector. So we are only multiplying the area of circle with theta by 360. Okay, let's try with one more example. Second problem. Find area of sector of radius 6 centimeter and angle 60 degrees. So in this type of problem, if you are ever getting confused, then you will do what? You will create the image first, the figure. You will create a very neat and clean figure. Na? So circle we are creating, radius is 6 centimeter. Of course we know that sector is area enclosed in between two radii. So it means we need two radii. Okay, this one and this one. Suppose center is O, this point is A, this point is B. So AB is the arc, AB are 2 points also on the boundary of the circle in such a way that we are joining them with OA and OB. So and OA and OB will become radii of the same circle. Now the angle between these two is 60 degrees. So we need to find the area of this portion. How? Again, given. You will write the given part. Given part is r is equals to 6 centimeter. So you can write this here also. Comma, theta is 60 degrees. Now, it is not mentioned that we should be taking value of pi as 22 by 7 or 3.14. So you can go with any value. Okay. So, therefore, area of sector is theta by 360 into pi r square. Now, theta value is 60 degrees by 360 into, I am going with 22 by 7 now, into r square means 6 centimeter square. So, 6 into 6. Now, this is divisible by 6, 1 6 and 1 6. We can cancel them. 22 into 6 is going to give me 132. 132 divided by 7 will be somewhere around 18.86. So the answer is 18.86 centimeter square. Again, if you are getting value anywhere in between 18.75 to 18.90, correct answer. Okay, so this is correct answer. Again, please be very careful about this. Whenever we are writing the final answer, we easily write the magnitude, but we always forget to write the unit. So because of this very silly mistake, you can lose half or 1 mark. So don't do this. Okay, always write the correct unit, and also area will always be a squared unit. So remember this, if centimeter is given, area will be centimeter square. Okay. Now, third problem. Now, this is a very unique problem. This is different than the previous one. Why? Here, the statement of the problem is area of quadrant if circumference is equals to 22 centimeter. Is radius given to us? No. Is theta given to us? No. But still, examiner is hoping that we should be giving him the final answer. How? How can we find the answer now? So there are something hidden in this problem. One thing, if in the problem it is saying that quadrant means 1/4 of anything. Okay. In case of coordinate geometry, you may have seen this term quadrant, no? There are 3 different quadrants, 4 different quadrants. Now, here also, if we are talking about the quadrant of a circle, so basically we are dividing that circle in 4 equal parts, and out of those 4 equal parts, we are only considering one part. So look at this circle. This portion is exactly the 1/4 of this entire circle. If this portion is exactly 1/4 of entire circle, then what is the value of theta here? Theta should be 1/4 of the whole angle. What is complete angle in a circle? 360. What is 1/4 of 360? 90 degree. So it means the angle between the radius is 90 degrees. Now, let me consider the center O and these two be A and B respectively. You can choose any name. Now, one more thing, radius is also not given. Do we know the value of radius? No, we don't know. But we know the value of circumference. Circumference is what? 2 pi r, the length of the boundary of the circle. Value we can find using the formula 2 pi r, correct? From that formula, we know 2 is constant, and we know pi constant, r we don't know, but the final answer we know, the value of circumference. So there is only one unknown value, that is r. So we can find the value of r from there. Okay, we are going to do that. Circumference is equals to 2 pi r. Value of circumference 22 centimeter. 2 into 22 by 7 into r as it is. So I am going to transpose every value on the left side, and I will keep only the unknown on the right side. So it will become 22 into 7, this is a division term, it will become multiplication term, divided by 2 into 22. 22 and 22 can cancel each other, this is equals to r. So the value of r that we are getting is 7 by 2 centimeter. I will keep it as it is, because we need to somehow find the area of this sector, no? And when we are looking at the formula of area of sector, it is theta by 360 into pi r square. Pi is having 7, no, in denominator, and r is having 7 in numerator, so they are going to cancel each other. So I am least bothered about converting this into decimal value. Okay, now let me erase everything. So for now you need to remember that radius is 7 by 2. So please don't erase from your final answer sheet. You can keep it as it is. Now we know that R value is 7 by 2. 1 second guys. R value is 7 by 2. 1 second. Now it came back. Okay. So let me erase everything again. R is 7 by 2 centimeter. And we know the value of theta. Theta is 90 degree. Now, area of sector. Theta by 360 into pi r square. Do we know all the unknown values? Yes, because we need only theta and r, no? We know them. Now, theta means 90 by 360 into pi means 22 by 7 into r square means 7 by 2 into 7 by 2. Now, 90 and 360 are divisible by 4. 7 and 7 can cancel each other. This 2 can cancel this 22 by 11. Now, what are we having now? 11 into 7, 77 and divided by 8. 77 divided by 8 would be 9.625 centimeter square. Again, please don't forget to write the correct unit. Area will always be squared unit. Okay. So this is how we can find the area of any sector if information is given directly or indirectly. Remember, quadrant means 1/4 of something. Here we are talking about circles, so 1/4 of circle. So using this info, you can find the angle in between the radius, and using the value of circumference, you can find the radius itself. There's one more way to find the answer of this. What is that? So I will give this you as an activity or homework. We know the value of r, or we can find the value of r using circumference, correct? After finding the value of r, find the area of the whole circle. Okay, that would be pi r square or pi into 7 by 2 whole square, correct? Because r value is 7 by 2. Now, after finding the area of whole square, divide that area by 4, because quadrant means 1/4 of the circle. So, area of this quadrant would be 1/4 of area of the circle itself. So, after finding the area of circle, you can divide that value by 4 and you will be getting the area of quadrant, and then verify if you are getting the same answer or not. Okay. First thing, what is a segment? As we know that sector is area enclosed or region enclosed in between two radii and the arc, correct? Segment is a little different thing. Do we remember what a chord is? We do, right? So a chord is a line segment joining any 2 points on the boundary of the circle, correct? In this figure, you can see A and B are 2 points on the boundary of the circle. Now, if we are joining these 2 points using a line segment, then essentially we are creating a chord here. This chord is dividing this circle into equal parts, not equal, sorry, in 2 parts. The upper portion, the larger area, and this one, smaller portion, the light orange area. Now, this is known as the segment of this circle. Also, this is also a segment. As we have seen in the case of sector, major sector, minor sector, no? Same applies here also. Minor sector, minor segment, major segment. First, let's understand how to describe this area. What is segment? A segment is the region enclosed by a chord, as you can see here, a chord and the corresponding arc. As you can see, this is an arc. So the region enclosed in between this chord and the corresponding arc is known as the segment of this circle. Now, if you apply the same logic, look at the area which is shaded orange in color. So as you can see, AB is the chord and this is the arc. So this is also segment. Yes, it is. So this is known as minor segment and this one will be known as major segment. Now you understood the difference? This one is larger in area, this one is smaller in area. So segment is that region which is enclosed in between a chord and the corresponding arc. Now main portion is not what segment is, but how to find the area of this segment. This is the main part. Now one thing, if we understood the concept of segment and what is major segment, what is minor segment. Now if in the problem it is given that you need to find the area of segment without any reference, if we are talking about major segment or minor segment, we will always consider that to be minor segment. If it is written segment, then we will consider the minor segment. Okay. Now there is no direct formula to find the area of segment. There is no direct formula, as in the case of sector we are having a direct formula, no, theta by 360 into pi r square. We are not having any area, very specific formula for the area of segment. So how to find the area of segment then? So there are three things that I can see now. One thing is that if I join the points A and B with center O, suppose O, then we are getting two radius, OA and OB. If you are looking at this circle, then you can see three different type of things. First thing, this sector OAB, this is a sector, correct? Now AB is the line segment joining both points A and B. So this AB will become arc. Let me take a random point C in between. So ACB is an arc. Now segment is this much, the light shaded area, no? This is my segment. If I somehow find the area of this sector and if I subtract the area of this triangle from the area of the sector, I will be left with what? Area of this segment. So we are going to do that only. We are going to find the area of this sector, then we are going to subtract the area of this triangle from the area of that sector, then we will be having the area of this segment or this portion. This will be our approach. So that's why area of segment is equals to area of the sector minus area of triangle. Understood? We know how to find the area of sector. We know what is area of triangle. No? So area of sector is theta by 360 into pi r square. Area of triangle is half into base into height. Easy? No problem? There will be a little bit. What is the problem? See, area of sector we can easily find if we know the value of theta and radius. What about area of triangle? Okay, we can find this easily. We have been doing this from a very long time. We know how to find the area, no? But one difference is that in problems, you will not be given the exact value of base and height. You need to find them first. How to find the value of base and height then? We are going to use trigonometry here. So using trigonometry, we can find the value of base and height. How? Do we know the relationship between the sides and the angle of any triangle? If suppose the value of this angle is given to me, if I am looking at this triangle, in this triangle I can realize one thing, that this angle, this side and this side, they are equal because they are radii of the same circle. So it means this side and this side are equal. So what type of triangle is this? At least isosceles, correct? Now, if it is an isosceles triangle, then the angles opposite to equal sides are also equal. So it means these two angles are equal. Now, if I draw the median from on that side which is not equal and from the opposite vertex, then according to the properties of isosceles triangle, this median will be dividing this triangle into equal parts. So it means these two triangles that now we are seeing are uh, the congruent to each other. Of course, if you want to prove them, you can prove them also. Let me tell you quickly. This is 90 degree because perpendicular. Now, so it means we can go for RHS congruence rule. So this side is equals to this side and this side is common. According to RHS congruence rule, if in any two right angle triangles, the length of hypotenuse and any one of the corresponding sides are equal, then the two triangles are congruent. So in these two triangles, hypotenuse are equal and one of the side is also equal. So these two triangles are congruent. Using trigonometric ratios, also using the property of isosceles triangle, the median will be dividing the angle into equal parts, correct? So suppose whatever the value of this angle is, suppose theta, it is theta by 2, okay, whole angle is theta, theta by 2 it is. So using this angle, I can find the value of this portion, this side and this side. This side, if I know the value of this side, then the whole side is nothing but the double of this portion because they are equal, correct? Now, how to find the value of these sides? Sin theta, cos theta, correct? Because we know the length of hypotenuse, radius must be given in the problem. So using this approach, we can find the height and base of this triangle. Then we can easily find the area of triangle and then we can subtract this area of triangle from area of this sector and we will be left with area of this segment. So this will be our approach. Okay, sounds confusing, no? Now let me show you one or two example, then you will be clear about this. So example on this, how to find the area of segment. If you are given any problem, okay, and you are getting confused, so you will do what? You will create a very neat and clean diagram first. So we need to find the area of segment where r is given and theta is given. Okay, we are given all the necessary information. So I will create the diagram first or figure. Okay, now if suppose this is the segment, let me name the points A, B, center O. So we need to join these two. So what is given to us? Angle between these two is 90 degrees. So this angle is 90 degrees. Also radius is 10 centimeter. So 10 centimeter. This is also 10 centimeter. First, I will find the area of this sector because I need area of sector, area of triangle, then I can subtract them and I can find the area of this segment. So we need to find the area of this portion, shaded portion, correct? Now, area of, let me name this point as C. So first, we need to find area of sector. What is the name of the sector? OACB. OACB is theta by 360 into pi r square. That will be theta is 90 degrees. 90 by 360 into pi means 22 by 7 into r is 10 square. 1 by 4, 2, 11. This 2 can also divide this. So right now it is 11 into 10 square means 100, 1100 by 14. So it will come, let me tell you the value, it is 78.57 centimeter square. Now we know the value of area of this sector, this whole value we know. The area of this sector we know, that is 78.57. Now let me write down this area of sector here. Area of sector is equals to 78.57 centimeter square. Okay, let me raise this portion because I need some space to find the area of triangle so that we can find the area of segment. Okay, now the main part, how to find the area of triangle. As I told you, we need the value of base and height. So first thing first, we are going to do one thing. We are going to draw a perpendicular from vertex O onto side AB. Let's name this point as D. Now this angle is 90 degree, so this is also 90 degree. In triangle OAD, in triangle OAD, what can we observe? We know the value of this side because this is radii 10 centimeter. Value of this angle is 45, exactly half of the 90 degree, correct? In triangle OAD, if we go for sine 45 degree, sine 45 degree means side opposite to angle, that is AD, perpendicular by hypotenuse, that is OA. Now AD value we don't know, we need to find. OA we know, that is 10 centimeter. So from here we can write down the value of sine 45, that is 1 by root 2 is equals to AD by 10. So therefore value of AD would be, transpose this to left side, 10 by root 2 centimeter. Now we know the value of AD. If AD is 10 by root 2 centimeter, then what is the length of AB? Twice of AD. So AB is twice of AD. So it is exactly 2 into 10 by root 2. So 20 by root 2 centimeter. Now we know the value of base. Base we know. How to find the height? OD. Now OD we can find using the same angle, but this time we are going to use different trigonometric ratio, that is cosine. So in the same triangle, cos 45 degree is what? Side adjacent or base OD divided by hypotenuse OA. That will be OD is unknown and OA is again 10 only. So cos 45 is also 1 by root 2, right, is equals to OD by 10. Therefore length of OD is 10 by root 2 centimeter. Now we know the base and we know the height also. So area of triangle is half into base 20 by root 2 into height 10 by root 2. Now 20 into 10, 200. Numerator divide by 2 into, okay, look at this, root 2 into root 2 square. Square and root are going to cancel each other. So what are we left with? 2. And 2 into 2, 4. So 200 by 4 is going to give us 50 centimeter square. We know the area of sector 78.57. We know the area of this triangle 50 centimeter square. So now let me write triangle area of triangle 50 centimeter square. Now let me erase this. Now what is left? We need to find the area of segment. We know that area of segment will always be equals to area of sector minus area of the triangle, correct? So we can use this because we are having all the values. 1 second only. This portion will do. Okay. Now area of segment is equals to area of sector minus area of triangle. Both the values are known to us. Area of segment 78.57 minus area of triangle 50 centimeter square. So this is going to give us 28.57 centimeter square. So this is your final answer. 28.57 centimeter square. Again, I am telling you, please don't forget to write the correct unit. Area will always be a squared unit. So this is the correct answer. If you are getting answer in between 20.45 to 20.60, absolutely correct. So this is the correct way of finding the area of any segment. So the major portion here is not finding the area of sector, it is the finding the area of triangle, because here we are applying the trigonometric ratios. Okay, now you know understood the concept, now you can apply. Okay, let's see one more problem. So it's a very difficult one or different one, not the difficult, I shouldn't have used the word difficult, different I should be using. Same approach we are going to apply, but this time we need to find three things. Look at this statement. In a circle of radius 21 centimeter. Okay, circle is given, radius is given 21 centimeter. An arc subtends an angle of 60 degrees at the center. Okay, an arc means APB. This arc is subtending 60 degrees angle at the center. Okay, now we need to find the length of the arc. First thing that we need to find is length of this arc APB. Okay. Second, we need to find the area of the sector formed by the arc. Okay, so we need to find the area of this sector also. Also, we need to find the area of the segment. So, what is area of segment now? So, this arc that we are seeing is having two extreme points A and B. If we join them using a line segment, so now we can see the segment. So, this is my segment. So, this area also we need to find. Okay, first thing, how to find the length of the arc. Length of the arc. See, arc is just a portion of this circumference, correct? How we are finding the area of any sector? We are first deriving the formula using unitary method. First, we are finding the area of the circle when theta is 1 degree. Then we are multiplying that value with the theta itself. That is going to give us the area of that sector. Same method we are going to apply in case of arc. Suppose we need to find the length of any arc. So, whole circumference, when angle is 360 degree, then circumference is 2 pi r. When angle is 1 degree, then circumference will become 2 pi r by 360. When angle is theta degrees, so circumference will become, or the length of the boundary will become theta by 360 into 2 pi r. So the same kind of approach we are going to apply here. So this is the formula to find the length of any arc. Okay. Now we need theta, we need r. Are we having? Yes, theta is 60, r is 21. So let's find the length of the arc. So first, length of the arc is equals to theta by 360 into 2 pi r. Theta value is 60 degrees by 360 into 2 into 22 by 7 into r value is 21. Okay, they are divisible by 6 and this can divide by 3. 3 into 2 is 6, so we can divide this also. So what are we left with? 22. So 22 centimeter is the length of this arc AB. Fine. We know how to find. This is the formula, theta by 360 into 2 pi r. Same kind of formula that we are using in case of area of any sector. So this reminds me that we need to find the area of sector also. Area of sector. See, if you want it to be very clear na which sector you are talking about, so you can name the sector here. So what is the sector name? OAPB. So we are going to write OAPB. This will tell examiner that you are finding the area of which sector, correct? Minor only, but this will specifically tell the examiner that we are talking about this sector. Now, same formula we are applying, theta by 360 into pi r square. Values are known to us, theta is 60 by 360 into pi 22 by 7, r square means 21 into 21. Now, this divisible by 6, this 3. So, 3, 2, 11. 11 into 21 is gonna give us 231, correct? 231 centimeter square. This is the area of this sector OAPB. Now, this is again required. Why? Because we need to find the area of what now? Segment, correct? So, to find the area of this segment, this region, we need area of the sector that we are already having. Also, we need to find the area of this triangle, correct? So, to find the area of triangle, we need to apply trigonometry. Okay. Now, here in this diagram, we are going to join A and B. So, this is our segment. I am going to draw a perpendicular from vertex O onto side AB. As this is an isosceles triangle, so this perpendicular is dividing this AB in two equal parts. Let me name this point as D. So, OD is bisecting AB in two equal parts. Now, what is the value of this angle? OD is also the angle bisector of angle O. As the whole angle is 60 degrees, so this value is 30 degrees. You need to write everything word by word like this only, okay? Now, after explaining what construction you are doing, you are going to write here, in triangle OAD. First, I need to find the length of suppose OD. So, OD is the side adjacent to this theta, 30 degrees, correct? So, it means we need to go with which trigonometric ratio? Cos 30 is equals to OD, side adjacent or base, by hypotenuse, that is OA. Cos 30 is equals to what? Root 3 by 2. OD we don't know. OA is 21. Now, if you cross multiply, you will get value of OD as 21 into root 3 by 2 centimeter. Now, we are having the value of height, correct? We need to find the value of base AB. So, first in the same triangle, I will find the value of AD. Then I can multiply that value with 2. So, we will get the value of AB. So, sine 30 degree we need to find, because AD is the side opposite to the angle. So, sine 30 would be side opposite or perpendicular AD by OA. So, sine 30 is 1 by 2 is equals to AD we don't know and OA is 21. Therefore, AD is 21 by 2 centimeter. Now, as we need AB and AB is twice of AD. AB is twice of AD, so it will be 2 into 21 by 2. So, simply 21 centimeter. Now, we have the base, we have the height, we can easily find the area of the triangle. So, area of triangle OAB is equals to half into base AB, that is 21, into height, that is 21 root 3 by 2. Now, 21 into 21, 21 square. So, the value will be, let me tell you, the value will come out as 190.95 something. So, I am rounding it off to 191 centimeter square. So after doing all the calculation, because root 3 value is 1.732, if you find the square of 21, multiply that with 1.732 and divide that with 4, you will get 190.95 something. So I will round it off to 191. So the area of this triangle is 191 centimeter square. Now the only part that is left is to find the area of this segment, no? So let me take one more slide. One second. So I will do one thing. I will erase everything from this slide. I know that the area of triangle is 191 centimeter square. Okay, remember this. Area of triangle. One second, guys. Second. Yeah, it came. Area of triangle OAB. We need no. OAB is 191 centimeter square. Also, in the previous slide, we found the area of sector OAPB, that is 231. So to find the area of this segment, we just need to subtract the area of triangle from the area of sector. So area of segment, again I am going to specify the name, area of segment APB is equals to area of sector OAPB minus area of triangle OAB. We know both the values, they are 231, the area of sector, minus area of triangle 191 centimeter square will be the unit. So 231 minus 191 is gonna give us 40, correct? So the answer is 40 centimeter square. So the area of this segment APB is 40 centimeter square, and this is how you can solve this type of problem. So here in this problem we are solving three parts. First, we are finding the length of this arc APB. How? We are using the formula theta by 360 into 2 pi r. Why? Because this arc is nothing but a portion of this circumference only. So we know how to find this. Then second, we need to find the area of sector OAPB. If it is written sector, means minor sector. We know the formula, area of sector would be theta by 360 into pi r square, correct? Then to find the area of this segment APB, we need to find the area of this triangle also. So how to find the area of this triangle? We are going to use trigonometry here. So after applying the trigonometry, we can find the area of this triangle, that is 191. Area of sector was 231 centimeter square. Subtract them, you will get the area of this segment APB as 40 centimeter square. Again, unit is very important if you don't want to lose half or 1 mark. Okay, so this is how you can solve this type of problem. Now let me show you one different type of problem that came once in the final board exam. Here, as you can see, the image is given, the figure is given. So there is some normal portion and there is some shaded portion, correct? Now, one second. So we need to find the area of the shaded portion basically. But to find the area of the shaded portion, first we need to analyze the statement that is given to us. In the figure below, ABC is a quadrant. Again, the same word came, quadrant. If quadrant is given, then it means it is 1/4 of the circle, correct? Now, quadrant of a circle of radius 14 centimeter. So the quadrant is of a circle which is having radius 14 centimeter. So of course this is radius of that quadrant also, because quadrant is part of the circle only, no? And also if it is a quadrant, it is 1/4 of the circle. So everything is 1/4. Area 1/4, angle theta 1/4. Sorry for the inconvenience because of some technical issue, and now we are back, so we can continue. So this is the last problem that we are talking about. No, I was telling you what is given in this problem. So here the figure is given, correct? So ABC is a quadrant, so again it means 1/4 of the circle, correct? So if it is 1/4, then the angle that we can see here is 90 degree, because 1/4 of circle means 1/4 of the overall angle also, 360, 1/4 of 360, 90 degrees. So this angle is now known to us. Now radius is given 14 centimeter, so this value is given AC 14 centimeter. So AB is also 14 centimeter because they are radii of the same circle. Now, and a semicircle is drawn with BC as diameter. As you can see here, this is a semicircle. The diameter of this semicircle is BC. So somehow we need to find the radius of this semicircle, because we need to find the area of this shaded portion, no? So how can we find the area of this shaded portion? We can do one thing. We can first, let me show you how it is exactly behind. So if I separate them, so the image will look something like this quadrant and this semicircle. So we are making a combination of these two, correct? So it is like this. Now we just need to find the area of this shaded portion now. So how to find this area now? Let me show you again. Suppose if somehow I can find the area of this semicircle, I can, okay, then I need to find the area of this segment. Now what? To find the area of this segment, first I need to find the area of this sector, find this area of this triangle, subtract them, we will be having the area of the segment. Then we need to subtract the area of this segment from the area of this semicircle, then only we can find the area of the shaded portion. So this will be our approach, correct? So first thing, what is given to us? So the radius of this circle is given, this quadrant is given, that is 14. The angle is 90 degree, correct? So let us find the area of this sector first, this quadrant first. So area of sector ABDC, this is ABDC, no, is equals to theta by 360 into pi r square. Now theta is 90 degree, so 90 by 360 into 22 by 7, r is 14 into 14, 4, 11, 2, 2 and 7 can eliminate this 14. So what are we left with? 11 into 14. What is 11 into 14? 154 centimeter square. Now we are having the area of this quadrant or this sector, correct? Now we need to find the area of this triangle also. So in this triangle, it's a right angle triangle, no? So this is 14 centimeter, this is also 14 centimeter. So base and height are known to us. So area of triangle, triangle name is ABC, is half into base 14 centimeter into height 14 centimeter. So that will be 7 into 14. 7 into 14 is gonna give me 70 and 28, 98. So the area of the triangle is 98 centimeter square. Now we know the area of these two things, correct? So we can easily find the area of the segment BCD, correct? So area of the segment BCD would be 154 minus 98, correct? So area of segment BCD is equals to 154, the area of this sector, minus area of this triangle 98. So what is 154 minus 98? 56 centimeter square. This is the area of this segment BCD. Now we need area of this semicircle BCE. But to find the area of this semicircle, we must be knowing the value of radius, correct? We don't know the radius value. Okay, angle we know, that is 180. Or even if the angle value is not known to us, it is given that it is a semicircle. So the area of this semicircle will be the half of the area of the whole circle, correct? So pi r square by 2. Now, how to find the radius of this semicircle? One thing, BC is the diameter. So if somehow I can find the length of BC, I can easily find the half of BC, that will be the radius. BC is also the side of this right angle triangle, and that to the hypotenuse. So in right triangle, I should write ABC, we can apply Pythagoras theorem. According to Pythagoras theorem, the square of the hypotenuse, in this case BC square, will always be equals to sum of the squares of other two sides, AB square plus AC square, right? AB square plus AC square. So BC square would be 14 square plus 14 square. Now 2 into 14 square, correct? So if I take the under root on other side, so BC will be under root 2 into 14 square. Now under root 2 will remain as it is, 14 square will come outside, so the final value would be 14 root 2 centimeter. So this is the value of BC. Now we know the length of BC, and the radius of this semicircle is exactly half of BC. So it means, suppose this is a point here. So the point is F. So BF is the radius, that is half of BC, that is 14 root 2 by 2, 7 root 2 centimeter. Now we know the radius. Okay, how to find the value of, or so the area of this semicircle? Now let me erase everything. 7 root 2 is my radius. So one second. So area of semicircle, this BCE, is equals to pi r square by 2. Now pi 22 by 7 into r square means 7 root 2 whole square, 7 root 2 whole square by 2. So 22 and 2 are divisible, so 11. So 11 by 7 into 7 square means 7 into 7 into 2, root 2 square means 2. 7 and 7 can cancel each other. 11 into 7, 77 into 2, 154. So this will be 154 centimeter square. So this is the area of this semicircle, 154 centimeter square. We know the area of this segment, that was 56 centimeter square. So we need to subtract these two values only, correct? So let me erase everything. So area of, one second, this got stuck, one second. So basically we know the area of this semicircle, that is 154 centimeter square, and also we know the area of this segment, that is 56 centimeter square. So area of shaded region, shaded part also, is equals to area of the semicircle BCE 154 minus area of this segment BCD 56 centimeter square. This is gonna give us 98. So the area of the shaded region is 98 centimeter square, and this is how you can find the area of this portion. Now you understood how to find the area of this shaded portion. First we are finding the area of this sector, because it's a quadrant, so angle is known to us, we can easily find. Then we are finding the area of this triangle. This is also easy because this is a right angle triangle, so base and height are equal. Now after finding these two, we can easily find the area of this segment, correct? Done. Then we know that it's a semicircle, so the area of this semicircle will be the half of the area of this whole circle. we can easily find, but before that we need to find the length of BC, because that is the diameter. Using that we can easily understand the radius, that is 7 root 2. Using that information we can find the area of this semicircle. Then after finding the area of this semicircle and this segment, we need to just subtract them, and we are left with the area of the shaded portion, that is 98 centimeter square. So it's a very easy problem. We just need to perform too many steps only. That is the only problem here, that you are going to find the answer in too many steps. The calculation is very easy, no? So this is how you can approach this type of problems. So we are done with this chapter. So in this chapter we talked about the introduction part, what type of different areas you can expect, what are the different terminologies you are going to apply in this chapter. Then we saw how to find the area of any sector, what is a sector and everything, and then we saw how to find the area of any segment. We even worked on some problems which are a combination of different sector and segments, and how to find the area of those, even the shaded portions. So we are done with this chapter. I hope you understood everything. If even if you are still having any doubt, you can do one thing. You can tell us your doubts in the comment section. We are going to address them. So till we meet next time. So bye bye from my side. So we'll meet you again with some other things. So till then, bye bye. Please stay happy, stay healthy. We'll meet you soon.